So welcome to session two. We are going to talk about uh, in the last chapter we learned about what is our bash shell environment in Linux, and we learned few basic commands, and we even write couple of scripts which are like starting steps, uh, uh, starting steps in our shell scripting journey, right? I would call it as. So we also we will be learning more today about the process management and job control. Okay, so this information, the process control or job control, is more really useful for anybody who works extensively in Linux environment, right? Be it as a admins or be it a production support, be it somebody like whose production environment is depending more on Linux servers, right? So in this chapter, we are going to learn about a command called PS, and we will learn more about how to work with manage the process. Like there are a few things that happens in Linux where you can make the process to run it even in the foreground, background, or you can even schedule the jobs or kill any particular process um, uh, as such, right? So, and we will also learn about few scheduling jobs, scheduling um, tools in Unix. One is that at command, another one is cron tab, right? So with no doubt, let's get started. Okay, and to start with, right? So a running process of a program is called a process. So even if you run Windows, if you go to Task Manager here, you would be able to see the process that are running on the system. Correct? Just to correlate between what is the uh, how Windows behaves and how Unix behaves, right? So every system, every activity is something we call it as a process, right? A to keep it in a book definition, right? A program stored in hard disk or a pen drive, eh, which we don't call it as a process. Like think about this: there is a file that does exist in my system, in my C drive or D drive, right? So we don't call it as a process, right? When the stored program starts executing, let's say I have hello world.sh or test1.sh, which we created the other day, right? When I start executing it, that execution we call it as a process, right? um, so let us understand how the boot up starts, how the system comes up. So what happens is, in any PC for that matter, the BIOS chip initializes system hardware such as PCI bus and display drivers, etc. Right. So this BIOS executes a bootloader program. Okay, you might have read more in computer organization if it is part of your curriculum. Right? The bootloader program then copies the kernel into the memory, and it does certain basic checks. In especially in kernel, right? In Linux related system, there is a program called start underscore kernel off. Okay, I'll just write it here for everybody. Start underscore kernel. This is a program. It gets started when to do the basic checks in the kernel. Okay. So when the kernel starts, it initializes the OS and creates a first process called init. Right. So to talk about this init, sorry, it's a typo. Init. So to talk about more about init, right? So what happens is like think about this. You are a web administrator, like who manages certain web programs like Apache Tomcat or IBM WebSphere. Is there a question? JBoss, like that, right? So JBoss, right? So in such cases, right? Okay, I'm muted everybody. So in such cases, right, we'll add that startup process into init. So in Windows, right, there is something called shell startup. Okay, so this will get this one. So I have a OneNote here. So when I keep anything here, right, so let's say Notepad, I want my Edge browser, I want my text pad, Notepad plus plus, anything that you create a shortcut here, so that will be brought up as part of system startup process. In other words, right, when I'm bringing up the system, so all those programs will also get invoked. Correct. So such way, like, we call this as a init process. So along with the init process, there will be certain certain applications we will bring up as part of our day-to-day process. Okay. So this will be typically taken care by admin folks. And I have what I did is I have bought an Amazon instance. Okay, let me restart this. I have bought an Amazon instance for this class, right? So what happens is, like, this is a free tier instance where I don't have to pay at least a single NP for this. And I'd be able to show you, like, how the real-time servers looks like. And this is a putty tool. I'll have another session about this probably when we get towards the end. Probably I'll show you, like, how do we launch Linux instances? How do we play with it? Because when you launch instances to AWS without any knowledge, you'll be charged. Your bank account will get cleaned. So that's the reason I'm not getting into it. But remember, like, I have an IP address and I logged in using a putty. Okay, so for that matter, now getting into the command, right, you can check the presence of any process using a command called ps-ef. Okay, these are all the processes that are running on my machine. My machine as in Linux machine, right? So you could see that, I have a username, process ID, parent process ID, and we have a time when it started. And I also have the time of execution followed by the command. So this is a systemd command, and this is a bash command that I have it. And I executed a ps-ef command that was running when I have executed this ps-ef command. Even that is appearing here, right? System date is appearing in UTC. So right now the system time is 6:14, and when I executed the command was 6:13. That's the timing that is appearing here. Clear, folks? So every process, like I was explaining, right, every process in Linux does has certain numerical identification that we call it as a process ID. So if you could see ps-ef command here, right? So there is something called 5138. This is the user ID that I logged in, and 5138 is a user. Sorry, 5138 is a process ID that was created for this command execution. Okay, you could see, like, let's look for for some reason network is dropping, but still continue to work and zoom. So let's look for that init process that I was talking about, right? So that init process will have user ID as a process ID as 1, and it would have created, you could see this here, right? Systemd process. So that's init process, but since I picked up Red Hat Linux, they are calling it as systemd process. Okay, it depends on one process, one flavor to the other flavor. But though the command name differs, so the command name systemd is executing, but we term that as init process, be it any flavor there. Okay. So we spoke about certain system calls, right? So how shell sends a system call to kernel and then to hardware, and we get output, right? So in same way, like, when the Linux OS in the Linux OS, right? So every new process is created using a command call, using a system called fork. Okay. Um, so what happens is when the fork of call has been sent, every process will have a process ID. Like I showed you in my previous screen, when I executed this ps-ef command, I have a process ID that got created, and I have parent process ID that does it. What is the parent process ID? The shell where I was executing this. If you could look at this 5148, the same number appears as a process ID here. So for my ps-ef command, the bash shell that I opened is my parent process ID. Okay. So to show you better, I have a command called ps-tree. So what happens is with this, like you will see like how the process how this process tree is segregated, which process has started what. Okay, so if you could see is there's a init process that I was talking about. That init process is a parent process for all this network manager. To there's something called Cron, audit d. So all these are like system related process, and it has started sshd as well. And then sshd, there is something else invoked, and bash is invoked, and that's where I have executed this ps-tree command, right? Like this, you would be able to see that. So when you have like 100 jobs that are running and you don't know which process, which command is running the job, you would be able to check that using ps-tree command, right? So there are few terms that we have to learn in this when we are talking about a process in Unix. Orphan process. Okay. Let's think about this. Now I was talking about the process ID and parent process ID, right? So think about this. There is a process ID that is terminated. Right? There is a parent process ID that got terminated, and that terminated process ID is a parent process for another process, right? So in this case, so just to show you what the example, right? So when you executed ps-ef, IC5148 is a parent process ID. So let's say if I have terminated this parent process ID for some reason, and still this process is running in the background. So in ideal scenario, ps-ef will not run in the background, but think about this as a shell script running in the backend, right? So this process appear to be as orphan process ID. So some process with no parent process ID is termed it as orphan process ID. Okay. So we will not have much of impact with that. The only reason is the execution might have impacts due to it. Okay. In most of the cases, it will execute as is, but there are certain cases where it doesn't execute as expected. Okay. So another one that we wanted to learn is zombie process. So to talk about it, right? So every process has one data structure called process control table within Unix. So that table will not be able to view it as it is being maintained by operating system. So that table contains the information about child process that are created by parent process. Now I'm talking about a bash process 5148. So that table, process control table, will have how many child processes that it has created. Okay. In this case, ps-ef is one of the child process to the process ID called 5148. Right. In the same way, like how many child processes that that's created will get recorded in that process control table. Right. So if by any chance, let's say if a parent process is sleeping or it is suspended due to some reason, right, the child process is terminated. Think about this, like I'm terminating this this complete putty session. So which means that I'm terminating a shell. So all the process that are executing on that instance would be terminated. Okay. So unless you're running it in the background, which we are going to learn in few minutes. Okay, such process. So, in certain cases where the child process will not get terminated, that process will turn as zombie process. Okay, you guys are following? You want me to repeat? Hello, is everybody awake? Unmute yourself to speak. Okay, so assuming you are following me, let me repeat. So what I was trying to tell you is, if the parent process is sleeping or suspended due to some reason, the child process will get terminated, right? Then the parent process cannot receive the information about the child process terminated. In such cases, like so in such cases, right? So where the parent process was inactive, or it will not receive, it have not received any response from the child process, right? Um, the child process that was terminated is something we call it as zombie process, right? When the parent process awakes, it will receive a signal regarding a child process termination, and process control back the data structure will be updated, meaning it will be updated back in the process control table, saying, the child process has been terminated or completed or anything. So simple scenario, right? So when somebody is going out of your room, right? When you are sleeping, and you will get to know only when you look around, meaning your eyes are sending a signal to you saying, like, somebody have left your room. So you will understand that, somebody is not in your room, right? So simple as that. Okay, and the next one is daemon process. So right now, we started every process using our bash terminal that you got to see in our screen, right? uh, in a similar way, right? Think about this. If you print anything with echo command, so what does echo do? Like we discussed in last like we discussed in last session, so it will print the data. So it will print the data that we have next to echo, right? So it will be printed in the terminal itself, correct? And there can be a certain process that are not associated with any terminal. So such processes, we call it as daemon process. So to bring you right, a new terminology called background process. So this is the best one. So the daemons are started back in the which are running in the backend. So it might have triggered because of a scheduled job or any external forces. In all such cases, such process we call it as daemons, right? Um, so we are going to see a few of such processes soon. Okay. Um, so let's get there. So I hope you don't have any questions, and this the uh, you know the lecture I just spoke about, right, is very important to move forward. Okay. So let's understand more deep into the PS command first. So PS is a command which gives us, like, what are the processes that are running. Okay, so we have a multiple options to pass it for PS command. If you do man PS, you'll be able to understand, like, what are the commands that we saw, what are the options that we have, and you have a description about that. Okay, so excuse me. So you could see that, to see every process on the system using the standard syntax PSF and EF, E capital uppercase F, ELY, we can use these things. And like, there's something called BST syntax and tree syntax that we talked about, right? So we have all these things, and I would encourage you to go through this in detail when you get into this Unix session. Correct. So, and I'll explain few options that we regularly use. Okay, so think about this. Now in the PS command that we have executed, let me clear. So you just see only the process ID, correct? So if you wanted to see like, the parent process ID associated with that, I'll use PSFNF. So with that, you would be able to see the user ID, process ID, parent process ID, and start time, terminal, time it took for execution, and the command, correct? So here, if you look at it, it's a command name is PS because I have executed the PS command. And here you would be able to see PS-F because I have executed PS-F command, right? So to see complete list of process, right? Uh, to see the complete list of a big list of process, so we have something called PS-LF. It gives an even bigger list. So here you see that start time, terminal. In addition to that, we have our address, location, and everything. But these are not much of needed. Um, but there's a one way of getting the things, right? So it gives the state, so which talks about the state of the process. Okay, R for running and S for suspended. So bash is something that has been invoked by our init process and it got suspended there. Whereas ps-lf, when I have executed this command, this was running actively. So that's where we got a R here, right? So to list all the process that are running in this operating system right now, with the above commands, ps command or ps-f, ps-lf, we got to see only the process that are running on our terminal. Okay, meaning that process that you have triggered, correct? So if at all, if you wanted to see what are the process that are running completely in the system, you use ps-ef. You could see that even the root user or Paul Kit D is one other user, RPC is another user. Um, you know for every user who has been running anything on the system will get displayed using this ps-ef command, and it will have the long listing as well, like to show you the header, right? So you have a user id, parent process id. It's a simple, right? When you execute ps-f, you will get only these things. And for this terminal, what I'm doing is I'm adding a e as I. So we have added another E here to the options, which will give us the complete list of processes that are running on the system, correct? So you might understand, what is few process doesn't have any square braces here, and few process does have square braces and doesn't have square braces. You would be able to see in the text that I have highlighted on my screen. One command has like square braces and other one doesn't have square braces, right? So um, the process, the commands are which are named in square braces is more like kernel threads. Remember, like I was talking about um, uh, I was talking about the init command, the process that init command, init process has started, systemd process. Those are appearing in square braces. Okay, so right now we have many processes that are listed. How do we know, any particular process that is really creating really that you are interested in, right? So what I'm going to do is I'm going to use a grep followed by a pattern. So we will understand more about this, but right now I only have a process pattern called SSH. So in this scenario, so whatever we have SSH, right, all the text will be displayed here. Okay, we will learn more about grep, but think about this. If I wanted to check for any particular process in pattern, we can use this one. Okay, so Let me open another session to show you, like, how we can kill a process. Correct. Um, this one. Right. So I'm executing top command again, which we have discussed earlier, right? So this will be running, like, this kind of more real time, where this will give this keeps changing, like what are all being executed and what are the top consumers of CPU utilization and how much CPU it is being used. You could see that, the CPU utilization here. Um, so how many tasks we have and what is the uptime. You could see everything here. Percentage utilization, I think this user utilization and system utilization and nice process IDs. ID is for idle. I think it's 100% idle and now 99% idle, and this number keeps changing. Okay. So based on our utilization, right now we are not using any CPU utilizations on the system because we are not running anything here. Okay. So guys, were you able to see my screen earlier when I executed top command? Okay, let me start sharing other terminals as well, which I have skipped in my previous command. So now you would be able to see that, yeah, I'm sharing a command for a command output of top, right? So you could see that this is keeps fluctuating or keeps changing, which indicates this is a more of real-time monitoring on the of the server, right? So you could see percentage CPU utilization, memory utilization, MAB swap memory utilization, and everything, which is not essential for us. So being a basic thing we just started with, you could see the ideal percentage of CPU. Okay, here this indicates this is 100% idle, meaning there's since there are no tasks that are being executed on this server, you would be able to see 100%, and only the consuming process that we are executing is the top command which we have executed. So let's switch back to the other window. Now if I execute ps-ef here, the top also should be listed here. Okay, and this is what it has listed. Now I wanted to kill the uh, um, uh, command called top, right? So kill followed by -9 for force killing it, and we can use 5294, the process ID. So remember, the first one next to the user will be the process ID, and the next one is PPID, call it as parent process ID, and the process ID we often term as PID. Okay, so if I give this and execute the ps-ef one more time, you'd not be able to see top command here, and this is terminated. You could see that, the cursor is moved to the next line and it is killed. This process is killed. So that's a command to kill any process that is running on the system. Okay, so remember, when you are terminating or killing any such process, you should be in a position to estimate what is the impact of killing that process. Okay, what if the process is not killed? So you have to assess yourself before doing it. So to assess that, you need to understand what is the intent of that process. Okay, so which you will be able to understand after going through what does that command will do, what does the script that you are trying to kill will do. You have to assess yourself for that first, and before taking a call to kill any process or session. Okay, so otherwise, like, we also have like um, uh, a way to kill a process. So let me start executing this top again. So, and you don't see the new prompt at the end. And um, if you do execute ps-ef one more time, you should be able to see the top command, and you can kill even this one with um, uh, process name. we use a command called pkill-9 followed by top. So the problem with this one is, like, think about this. There are, I have logged into the system. I'm executing top command. There is somebody else who also logged into the system, right? So they are also executing top command. So in such cases, there can be a conflict. So let's start. Let's try to use the only the process ID in any of the cases. It comes a handy. It will be typically 4-digit or 5-digit or 6-digit in numerical value. If you, much better to use than comparatively with any other command name there. Okay, right? So, and one more thing that comes here is like, okay, to show you that, right, if we move to the next terminal, you should see that, the terminal, the control came into the next line. That process is killed and it came here. Okay. And to check for all the various blocks of kill, right? So you can use kill-l. So it starts with, it gives so many signals here, right? So we are using only signal killing here, kill-9, and remaining are not so necessary, but you can start exploring this when you get into the real admin job. If somebody gives you a command and kill followed by some 50, if you wanted to look what is 50, you should be able to use this kill-l command. Otherwise, like, we would not need it, right? Okay. So let's talk about, what is a process management here, right? Now that we understood the command to check the process. So what are the commands that we learned? We learned ps-f, ps-elf, ps-ef. We learned all these things. And how do we kill a process? Using a kill command, right? So in typical bash shell, when we enter any command, right, or start any program, it starts running in the foreground. Think about this. I've executed echo hello world again. Sorry, echo hello world again. It will start echo hello world. It starts executing in the foreground itself. Okay, what's wrong with the keyboard? Echo hello world. It will be running in the foreground. In such situations, right? So you'd not be able to run more than one command in the foreground. You can run either hello world or any other command that you want to run. All right. In such scenarios, we have a feasibility call to run any command in the background. Okay. Meaning like even so to keep it in more realistic way, right? You have executed a script, okay, which takes about half hour. So when you execute it on your terminal, it will be running and you'd not be able to do it in the same terminal. You can open another terminal and do it. But think about this, there is a limit even for opening a number of terminals in certain scenarios. So to consider that, or, there can be a scenario where you lost your network, right? So in such cases, the process that you are executing in the foreground will get killed automatically, or it will not execute as expected. So in such cases, we need something to run it in the background. Okay, so let's create a script. Okay, let's create a script. V8 test1.sh, right? So escape I. So what I'm going to give shebang line bin slash bash. This is to test background process, correct? And I'm going to give author sheet, right? So here I'm going to print echo hello world. script again, and I'm going to write this to slash home slash ec2 hyphen user, this is a path, and write it to test1 dot output. Now I have written the test1 dot sh script. I'll be executing this. So what are the ways to execute this? So I'm using sh followed by test1 dot sh. It has executed, and it should, as per the script, it should write the output to test1 dot output file. So if I list this, I should have a file with test1 dot output, and it has executed this. Shift insert. It has executed, and then I got the output file. Okay. In similar way, if I wanted to execute this in the background, right? So I'm going to tweak this a bit, the script. I'm going to add another line, echo program to test background execution. So remember, I was talking about redirection operators. When I give one greater than symbol, it will overwrite the file. When I give double greater than symbol, it will append the content to the existing file. Okay. So I'm executing this one more time in the background. So to execute that in the background, what I'll do is I'll add ampersand. So in this scenario, think about this. In this scenario, the execution will take um, a part of a second. There can be scenarios where the process might be running for half hour. In such cases, this ampersand symbol at the end will leave the terminal for you to work on something else where the job will be running in the background. Okay. So if you click on this, so you would be able to see the process ID that got created. Okay. And when it is completed, when you are working on it, similar like this one, this output will appear here. Okay. So if you check in the file now, the output file, you'll be able to see this, the extra line dot printed here. Hello world program to test background execution, right? So that's how we use the background. Okay. So to better help you with more, I mean, better example, right? I'm just thinking about, using a sleep command. So the same script, we're going to use a sleep command for certain time, which will help us to understand what is the process that is running in the background and how we can continue to work on the foreground. Okay. So we'll use a simple sleep command. Okay. So before we get there, let me edit the script. Right. So what I'm going to do is I'm going to put sleep 10,000 seconds here. Okay. So let me save this. So what happens is, to show you the difference, right? First, it will execute echo hello world and it will start sending the output to test1.output file. Since it has a 1, so it will replace the existing content in test1.output file, and it will create it as a fresh file with the same name. And then it will sleep for 10,000 seconds. And then, this will be printed. So let's reduce this to 200 seconds. I mean, 10,000 seconds is too much that we cannot wait so long. So 200 seconds is what, like 3 minutes, 20 seconds, right? So let's execute this. I'm going to execute this test1.sh file in the background. Okay, so now I got the process ID created. So if I do ps-36, you see that there is a, okay, so there is a process that does exist here, right? And sorry, this is the script that we have executed. Okay, Okay, ignore this output. I just accidentally copy pasted this. So this is the script that we have executed, right? And we are using another command, sleep to 200 in the script itself. So that is got invoked, and I have executed PSEF. You could see that process in the uh, PS-EF list. Okay, so just to go one step back, right? So in our previous session, we talked about interpreters, where it does create some disadvantages of Unix. So where it does create a process for every line of execution in the shell script, and this is a perfect example for this. So even though we have a process that does exist, and it has created another process ID in the it has got created another process ID even for sleep command that we have kept it here, right? One moment, please. Okay, here we go. So now let's look at the output of this output file. So this has executed in the background and it gave me some output here, which I'm not able to read it. So let's see this. So now it has completed 2 minutes and it has completed writing it. So when did we execute this program? 6:46. After 180 seconds, it should have been completed. So considering that the process should have been completed after uh, after 3 minutes, 6:49, it should have been ended. Okay, we could have printed this date as well. Okay, so now one. So this process completed in the background and has written this text file to us. Okay. So now let's say I'm editing this file to show you how do we terminate that process. Okay, this time I'm going to give 20,000 seconds here. Okay, and I'm going to execute this in the foreground. Okay, so I'm using test sh followed by test1.sh. It will keep executing, and to terminate this, I have to use a command called control plus C. So hold the control key in your keyboard and hit C. It will get completed. Meaning, like, it will not get completed, though it will get aborted. The execution will get aborted. So this is a lively example where you would be able to terminate your program running on your terminal. Okay, without using kill-9. If let's consider if this is a background process, any interruption will not, even if you give control C or even if you close your terminal, it will not interrupt the session in the background. Okay, so that is another advantage why you use background process. Okay. Okay, so now let's give a few more commands, like, I'll give it here itself. Sleep 10,000 if I give here. So to terminate this, again, I'm using control C. So the same command I'm executing in the background. So you'd not be able to see anything, and you can continue working in the foreground on your terminal, right? So same thing, I'm giving another command called sleep followed by 20,000 seconds and give executing in the background. I'll give another sleep command with 30,000 in the background. Now we don't know what are the background commands that are executing. So to know that, we'll use a command called jobs. So that will list you all the commands that are running in the background. You follow me? Okay. So so this is one thing, and think about this. This is a process ID next to it. I mean background process ID. and this indicates the running status of it. So now if I wanted to bring up something into the foreground, what I'll do is follow FG followed by the process ID. I wanted to give one here. So you see that command is appearing here, and it will get the terminal will be sleeping until like next 10,000 seconds. I mean 10,000 seconds from the time we started, and it will continue for the remaining in the foreground. Okay, in such cases, like I'll just kill this. I use this FG just to show you how we can bring up the process to the foreground. Okay, so that's about process management. Now we talked about let's see, like if we can touch upon the process monitoring tools. Okay, so we already spoke about a command called top, where it will list all the process in real time. You'd be able to see the CPU utilization, memory utilization, swap memory on your screen. Okay, so here the most important thing is the uptime of the server, and number of users logged in, and how many processes running, right? How many processes are sleeping, how many zombies we have, and you could see that the core utilization of CPU, like how much percentage it is idle. Okay, so these are the few things that you have to understand. And remember, guys, so when you execute this command on your server, right, and you read through this, that's the best way of understanding the output of this command. Okay, so top, we looked at it, right? And we understood like what are the lines it does indicates, correct? And let's look at something called IO stat. Okay, IO stat is command not found. IO stat -c command not found. Okay, I'll pass this command here. Probably I'll explain you in later session, because I don't have it IO stat installed on this one. Let's look for another command called VM stat. Okay, here is a go. So this VM stat, IO stat stands for in the previous command, right? Input output statistics, right? And what it does talk about is check the input output devices utilization. We use IO stat, and I'm not sure if I have a permissions to execute IO stat, but however, like we can use certain options in real-time environment if we have admin privileges to see, like the CPU statistics or disk statistics. So how many input output operations that are happening, you'd be able to see that in real time using IO stat command. Since this is a test instance, I don't have option, I think. Okay, and next I'm talking about a VM stat command, which gives a virtual memory statistics. Okay, so you could see that how much is the swap memory, how much is the free memory, buffer, cache, and all those memory things here. So the most we are worried about is free memory. In case if we get any alerts about a free memory, swap memory, we would be able to check that using a VM stat commands. Okay, that's typical IO and process monitoring commands that we look at it. Okay, so I'll call it. Okay, let me stop sharing.